Welcome to Chapter 7. Now let us learn how to sketch titration curve using information given. Now let's look at the question. Okay, the question says that potassium hydroxide is titrated with hydrobromic acid. Hydrobromic acid means it is HBr. So from here we know that potassium hydroxide is a strong base. Hydrobromic acid is a strong acid. So this is a titration between strong base and strong acid, which we will get neutral salt, where the pH will be equals to 7 at equivalence points. Okay, so this is the basic idea that we have now. Okay, let's continue with question. Okay, another one, it also asks to suggest a suitable indicator for this reaction. Okay, so suitable indicator, since we know it is a neutral salt, the pH will be 7. So straight away we know that the answer will be bromo, dimol, blue. Okay, now let's start with calculation first. A. Okay, remember, in order to sketch a titration curve, we need to know the pH, and now we need to know which one is in the burette, which one is in the conical flask, or in the conical flask we name it as analytes. Okay, so we can see the complete information that we get is 20 ml of 0.1 molar of hydrobromic acid. Okay, meaning that we know that in the conical flask or the analytes will be hydrobromic acid, which is 20 ml 0.10 molar, and then our titrant will be KOH, which is 0.2 molar. Okay, so remember, pH before titration begin means that we only have HBr. Okay, when we only have HBr means that the pH will be less than 7 because there's only acid. Okay, so what we do is we know that inside there's only acid, so we can start to find the pH. Okay, so to find the pH, we know that HBr is a strong acid. It will completely dissociate and becomes hydrogen ion and bromide ion. So we are given 0.1 molar of hydrobromic acid. So we are going to have 0.1 molar of hydrogen ion as well. Okay, so the pH will be equals to negative log H plus, which is equals to negative log 0.1, and then we will get the answer is equals to 1. Okay, this is the pH for when there is only HBr inside the conical flask. Okay, so now we've got the first pH, that is 1. When there is no KOH added. Okay, remember to write down volume of KOH added. Okay, this is in ml. Okay, now next one, we have solved number 1. Okay, when there's no KOH added. Now we solve number 2. pH at half equivalence point. Okay, so remember, half equivalence point is referring to the half of the volume of the analytes. Okay, so half equivalence point means that the analytes will be only 10 ml. Okay, so so even before I find the half equivalence point, I would quickly go for the equivalence point first. Okay, first of all, I know that at equivalence point, the pH will be equals to 7. Why? Because this is a strong acid and strong base titration, which will produce neutral salts. Okay, so I will do this first at equivalence point. I will start with C first. Okay, so for C, it is MaVa over MbVb equals to 1 to 1. Okay, how do I know it is 1 to 1? Because KOH plus HBr, we are going to get KBr and H2O. So the ratio is 1 to 1. Okay, so the molarity of acid is given 0.1. Then the volume is 20. Then for base, it is 0.2. Okay, so what is the volume of base? Okay, so we are going to get the volume of base will be equals to 10 ml. Okay, so this is at equivalence points. Okay, so now I have the first volume that is at equivalence. The volume of KOH added is 10 ml. Okay, label here first 10 ml. Okay, so meaning here, later I will be drawing that, showing that this is equivalence point. Okay, this is a draft first and it's at 10. Okay, so if half equivalence points is easy. Half equivalence point means 5 only. Okay, at equivalence point we need to use 10. Then at half equivalence point we just need to use 5. Okay, so start straight away. Okay, but this time it is different. This time we need to find the pH at equivalence point. Okay, so how to find the pH at equivalence point? Okay, I will rewrite again the equation. Okay, remember the volume for HBr, hydrobromic acid, will not change because it is inside the conical flask. The volume that we can control is only the titrants. Okay, so we will get the number of mole equals to -3. And then for potassium hydroxide, we know that given is 0.2 molar of potassium hydroxide. And then the half equivalence point, just now we already find out it is 5 only. Okay, what does this have to do with finding pH? Because to find the pH, we need to find the concentration of OH minus. Only then we can find the pH. Okay, so now to find the OH minus concentration, we need to know how much do we have. Okay, or what is inside the analyte. Okay, is it left with KOH or is it only left with HBr? If HBr, then we use the H plus to find the pH. Okay, so let's look at these two values. If we look at these two values, the smaller value will be KOH. So now at half equivalence point, okay, at half equivalence point, KOH will become the limiting reactant. So it will fully react. So HBr will reduce as much as well. Okay, so finally, limiting reactant completely react, and then what we left is only with hydrobromic acid. Okay, means now our analytes, the solution, we only have neutral salt and also excess HBr. Okay, so to calculate the pH at equivalence point, we know that the excess is acid. So pH equals to negative log H plus. Okay, now to calculate H plus, this time you have to be very careful. We know it is mole over volume. Okay, but the volume is when both added together. It's not only acid only, it's acid and base. So it will become 0.025 liter. So our answer will be equals to 0.04 molar. So our pH will be equals to 1.4. Okay, so now we've got the second point, that is 1.4, meaning that from 1, then our half equivalence point will be 5. Okay, then remember the steep is for strong acid and strong base, the steep is from 4 to 10. Okay, maybe from here is 4, so the steep will be roughly from 4 until 10. Okay, where is a vertical line, but we don't label 4 and 10. Okay, now we go to the last one. After the addition of 30 ml of 0.2 molar of potassium hydroxide. So D, okay, I will rewrite again, KOH plus HBr. Okay, so remember, just now it is given 30 ml of titrants, that is our KOH. HBr will still remains the same because HBr is in the conical flask given earlier. Okay, so now we have 6 times 10 to the power negative 3 mole, and then acid is still the same. Now, just now at half equivalence point, KOH is the limiting reactant, where HBr is the excess reactant. Now, after we add in 30 ml of KOH, HBr smaller value becomes limiting reactant. So it will completely react. So our KOH will also decrease by 2. So we will get final, after titration complete, we will get 4 times 10 to the power negative 3 mole. Okay, again it is the same. Okay, now which one is excess? Our excess is KOH. Okay, if excess is KOH means it is basic. Okay, so we need to find the pH. It will be OH minus equals to mole. Okay, now this time how much is our volume? Our volume will be 30 plus 20. So it will be 0.050 liter. So our answer will be 0.08 molar. Okay, so our pH will be equals to 14 minus POH, so equals to 14 minus negative log 0.08, and we will get 12.9. That's okay. So remember, it is not that difficult to answer this question. You just need to find out what is the excess and what is the limiting. The pH will be based on the excess reactant. Okay, that's all for the calculation for titration curve. Okay, remember initial, half equivalence point, and after addition of more titrants, or titrant become excess. Okay, so before I forget, okay, so this one, if let's say this is 30, so just now our pH is 12.9. Okay, so draw this in a bigger scale, then that is your final answer. Don't forget